So we're still on 5-6. 5-6 is going to be something we're going to do for the rest of the week. So I just want to talk about the 7 steps you see here, okay? So the first thing you always want to do is factor the top and bottom. Now, the reason we factor the top and the bottom is so that we can find any matching factors. Those matching factors are where we find the holes. So you're just going to set that matching factor equal to 0. So if it's x plus 2, you set that equal to 0. That's where your hole is at. Then we can set those factors aside. And then we can find any vertical asymptotes. That's where the bottom equals 0. So where whatever remaining factors at the bottom equals 0. That's going to find us the domain. Because remember, all those first four steps, you can kind of condense down into one. We factor so that we can find the zeros of our denominator. We can find any holes and vertical asymptotes, because those are the things we skip for our domain. Remember, the horizontal asymptotes, they kind of have their own little weird rules. Today we're going to explore something called a slant asymptote. So we will talk about that. So the 3 things we've come across so far for this category: if the top degree is more than the bottom, you are always going to look to see if it's higher by 1, then it might have a slant. If the bottom is more than the top, I'm talking the degree, then it's always a horizontal asymptote at y equals 0. And then if the bottom degree equals the top, then you're always going to use the coefficients on the lead terms. Okay, that kind of is the word coefficient. There's by 1, there's a slant. Okay, so if the top is more than the bottom by 1, if the top is more than that, there is no horizontal asymptote, there is no slant asymptote. So if the top is more than the bottom by 1, there's a slant. If the bottom is more than the top, it's always 0. If the bottom equals the top, the lead term degrees are the same on top and bottom, we're going to use the coefficients on the lead terms. And it's always y equals the top coefficient over the bottom coefficient, whatever those coefficients happen to be. Okay, so those are kind of weird things about horizontal asymptotes. They're one of the weirdest type of rules, I believe. The other rules kind of just, we always kind of do the same thing. Here we have to compare the degree on the top and the bottom. Okay, and then remember, we're going to find the intercepts. Remember, the x-intercept is where the top equals 0. The y-intercept, you're just going to plug in 0. So, and then once you have all that information, you're going to put those asymptotes holes on the graph. You're going to put those intercepts on, and then you're going to look and see what you got. And many times what you have may possibly be that you need to plug in some more points. And like any function, you can plug in as many points as you want, okay? And 2, you got to remember, the graphs, if they're separated by asymptotes, the graph fills up every other spot. So it's never going to have a spot where nothing is there. So something will be in every space that fills the spaces between any kind of asymptotes that you might have, okay? So now that we've kind of reviewed the rules, and those are the same rules we talked about before, let's go ahead and let's take a minute and let's do a few problems together. Now, the homework so far that we have had, so this was the first one. That one you should have already turned in 5-6A. Okay, so hopefully you've turned that in. And then 5-6B is next. So let's talk about this real quick. Although the instructions say whatever the instructions say, please just follow the 7 steps. Now I've condensed them up on the board kind of into 4 steps where it says graph rational functions. The first step is kind of those, what was originally those first 4, because it all goes together. Factor it so that you can find the holes in the vertical asymptotes, which will give you your domain. And then horizontal asymptotes or possibly slant, x-intercepts, y-intercepts, and graphs. So you're going to want to do that for all of these. So I expect to see all of those. And that should then cover everything there. I don't need the range. So feel free to take the range off, okay? So the instructions don't necessarily follow exactly what the instructions say, okay? So we're going to do number 5 together from the 5-6B homework. So let's take a moment and let's do number 5 together. So these ones here on 5-6B have been kind of separated because they are our original rational functions. Yes. They are the original rational functions, kind of move left or right, up or down. So you can use some of that to help us. As far as this first one goes, there's no factoring involved. There's nothing we have to worry about. So there's no matching factors on top and bottom. So the factoring is kind of done for us. There are no holes. There's a vertical asymptote where the bottom equals 0, so at -1. So now we're ready to do our domain, which goes from -infinity, skips that asymptote, and keeps going. Okay, so kind of do all of those first 4 steps in one. Factor it. Are there any matching factors? No. Are there any vertical asymptotes? Yes. Take any points out that you need to from your domain. Okay. So I would not even go further without putting on the vertical asymptote at -1. Okay. So that's where I would start with number 5. Now, these ones are kind of unique because of the horizontal asymptote. The bottom is, like we had before, the bottom is greater than the top power. So it is 0, but we have that -2. So when you have a number on the outside, what does it do? It moves it up or down. So it makes sense. That's okay. So the horizontal asymptote is at -2. Let's put that on. Let's think about what we know about these traditional rational functions. This moved it to the left one. This moved it down 2. So you can use all that we know about our traditional rational functions in this particular, that reciprocal function. Okay. So now step 2 is done. Step 3 are the x and y intercepts. The x-intercept is where the top of our fraction equals 0. Well, there isn't. 3 is not going to equal 0. So there's none of those. And you can, well, let's do something. These ones are a little different. When it's not one complete fraction, let's set the entire thing equal. So technically what's happening is you are setting the function equal to 0. And this one actually does have one. It actually does, because of that -2. It took everything, kind of smushed it down. So we can solve, because we can move that 2 over. Watch what happens. We can move that 2 to the other side, and then we can cross multiply. So this is a unique, these ones are unique a little bit because of, like here, this one has a +2, but this one has a -2. So, okay. So let's cross multiply. We get 2 times x plus 1. And then we're just going to solve. So we're going to subtract 2 from both sides and divide by 2. So these ones, I'm sorry, you are going to have to set them equal to 0. You can't use the little trick that the top equals 0. Okay, so we do hit the x-axis at one spot, at 1/2. Okay, that's the x-intercept. The y-intercept's really nice. Remember, you just plug in 0. So you get 3 over 1 minus 2. 3 minus 2 is 1. So we hit the y-axis at 1. So we have our x and y intercepts. So now we need to graph it. Now we have a lot of the pieces already on the graph. And we can kind of see that we're going to follow this asymptote and go down and follow that one. So that piece is pretty much set already for us. And if you want to plug in more points, you have the power to plug in as many points as you want. Now we know there must be a piece over here. Is that piece here or is that piece here? Well, usually they're in opposite locations, unless on your X you have like a power. They're usually in opposite. So I'm thinking most likely it's down there, but we can check. Let's plug in -2. So if we plug -2 into the top function, we get -3 minus 2 or -5. It is down there like I thought. If we plug in -3, if we want to just verify one more time, we get -1.5 minus 2, which is -3.5. And as we can see, we're going to follow the asymptotes. Okay, so that is the step I want you to take. You will cover all of the things they asked for you in the domain if you do that. So please just go ahead and for each of the problems in the 5-6B homework, please just follow those particular instructions, okay? So just do my steps and then you'll get everything you need. Don't worry necessarily about their instructions, just follow mine. Just like I did problem number 5, do the other ones that way as well, okay? There's a hole only if there's a top factor and a bottom factor when in factored form that match. None of those will have any holes, okay? Only usually if you have some powers involved are holes going to exist, okay? So now I want to go on to question 12. So if you could find question 12 for me. And then we're going to do one from the C homework, okay? So let's take a look at question 12. So remember, these 4 steps kind of go together. So you got to factor it so you can find possibly, are there any holes in it? Then we can see if there's any vertical asymptotes, and then we can, yeah, okay. So let's get it in factored form. I'm first going to factor out a -1 from the top, just so then I'm more likely to find a matching factor on the bottom. So I'm just trying to get it into factored form. If I could write today, goodness. Ooh, sorry. Wait a second. That's a 4. I'm doing good math today. Okay. So it doesn't factor on top and bottom, does it? No, it doesn't factor. I'm sorry. There's no factoring involved. That's horrible. So that tells us there is no hole. There is a vertical asymptote where x plus 2 equals 0 or -2. So let's put that on there. So the domain only skips -2. So it goes from -infinity, skips -2, and then goes from -2 to infinity. So This graph is in two pieces. This graph is in two pieces. Okay, so next, now that we've got that, here's the first one we've come across where the top power is exactly one more than the bottom. Now, what's powerful about that is we do not have a horizontal asymptote. We have something called a slant. So let's talk about how we find that slant asymptote. Unfortunately, we have to do division. So you always like division. And you want to do always long division, okay? Now here's why. We're going to take and put that negative 2x squared minus 4x plus 1 on the inside, x plus 2 on the outside. But what's great is you don't have to do the entire division, okay? What we can do is we're going to do until we get above the 1. We don't even care about the remainder. We don't care about anything like that. We are going to, just do kind of the first two steps. So x goes into negative 2x squared, negative 2x. We multiply, write it down, add them up. And then the next one would be a 0. Okay. So we found our slant asymptote. Our slant asymptote is the line y equals negative 2x. Now we know how to graph lines like that. Those are just a line with a slope of negative 2 that starts at 0. Okay, so we got to put that line on there, and we're going to make it a dashed line. Okay, so let's do that. So we're going to start at 0. We're going to count down 2 over 1. I'm going to really stretch that 1 because I can't draw very straight lines. But I like to go till I am through any vertical asymptotes. Okay, and then I am going to put that as a dashed line. Okay. Now this is what's weird about when one power on top is exactly higher than one power on the bottom. We get these two pieces that either go like this, they go across the x's. So you're either going to get two pieces like that, or we're going to get two pieces like that. So we just have to discover what x's are they across from. So are they here and here, or are they here and here? Okay. So that brings us, unfortunately, to our x and y intercepts. Okay. The y-intercept is really going to give us a lot. I'm going to do that first. If you plug in 0 in the top, you get 1. If you plug in 0 in the bottom, you get 2. So at 0, I am at 1/2. So that tells me, I believe I have a piece right there. So that means I follow the x. I'm on either side of the x. So if I have a piece right here, I believe I'm going to have a piece over here. Okay. So you get these really strange pieces to it. If you do the x-intercepts, you got a little work to do, unfortunately. We're going to use the quadratic formula. And the quadratic formula gives us the following. I don't think it's anything really that good, but let's do it. Okay, so it's negative b plus or minus the square root of b squared minus 4 times a times c is negative 8. No, that would be positive 8. Negative 4 times negative 2 times 1 is positive 8 over 2a's, which is negative 4. So that's 4 plus or minus the square root of 24 over negative 4. I'm just making sure I did my so that's going to be 2 radical 3. 4 times, no it isn't, 4 times 6 is 24. So that is negative 1 plus or minus square root of 6 over 2. It doesn't matter. We're just going to throw them into a calculator because that's grody. Okay, let's see here. So let me just tell you what those values are. Okay, so our first x-intercept, when I did the plus between them, I get 0.2, 0.2 is close enough because on a graph you can't really do much more than that. And then if I put the minus between them, I get negative 2.2, okay? So I hit the x-axis at 0.2. That kind of makes sense, doesn't it? I hit the x-axis again at negative 2.2. So what we have found, you're always, for these ones that have a slant, going to be across the x, okay? So what we found is we follow those asymptotes. We follow that asymptote. Okay. These are bizarre, strange graphs, okay? And I did check in Desmos to make sure that I was on the right track and that everything was lovely and grand and good. But those are probably some of the weirdest graphs because we have what's called a slant asymptote. Now that only happens if the top power is exactly 1 higher degree than the bottom. So so that's not something we're going to come across a ton of because of the fact that many times that denominator has the same power or the powers match, and you use the coefficients. So that is probably, I would say, one of the hardest problems we have to do. Now what we're going to do is we're going to do one problem from the last homework together, just so we have a sense of everything you're doing. And don't worry about their instructions. Follow the steps that we have gone over every time, and then you'll cover all the bases, okay? So let's look at the 4-6C homework, and let's just talk about them for a minute. Let's just talk about the horizontal asymptotes. This power is more on the denominator, so the horizontal asymptote is going to be at 0. These powers match, so we're going to use the 1 coefficient on the top and the negative 4 on the bottom. These coefficients are what we're going to use because the powers match. So this one has an horizontal asymptote at 1 on the top and negative 2 on the bottom. And then this one we're going to have to do division on because the highest power is in the top. This is the only one that has a slant. Okay. So you're going to need to factor to see if there are any factors that match. I don't believe there are any matching factors. I don't believe there are any holes, unless when that one factors, there's a hole in there. That's possible. Okay. So do you want to do the slant one together? Okay, so let's do number 8 together. Yeah. Okay, so this one's 0. This one is y equals negative 1/4. This is y equals negative 1/2. And then this is the only one with a slant. You're welcome. Okay, so let's do number 8. We'll go through the steps required to do number 8, okay? So remember, the first step we're going to do is we need to get it into factored form. Now, the top has an x in both. And if we take the x out, we are left with something that is still factorable. So I'm going to factor that all the way. I'm going to factor that to be x, x plus 3, and x minus 3. Okay. Now, the bottom, if I take out a 3, I'm left with x squared minus 2x minus 3, which is a factorable quantity. So that one factored is going to be x minus 3 and x plus 1. So you will notice that the wholes occur if there's a matching factor on top and bottom. That's why we factor as our first step. So here, there is a whole at x minus 3 equals 0 or at 3. And then we are going to use the reduced form for the rest of our questions. We get to use the reduced form for the rest of our questions. Okay. So the next that lead us is a vertical asymptote. That's that remaining x plus 1 factor in our denominator equals 0 at negative 1. So I'm going to put that on the graph. Okay. So our domain not only skips our vertical asymptote at negative 1, but it does have a hole that it has to jump across at 3. So just go in order from least to greatest number line order. We're going to go from negative infinity up to negative 1, jump across the vertical asymptote until we get to the hole at 3, and then we leap across it. So step 1 really encompasses holes, vertical asymptotes, and domain. They all go together, so you can think of it as one thing. Next, remember this is the one that has a slant asymptote. So for the slant asymptote, you get to use the simplified version. That x squared plus 3x is the top and 3x plus 3 is the bottom. Now the reason I write the whole thing out like that is because I have to do division, and so I need to see like everything that's there. Okay, so I'm going to put on the inside x squared plus 3x plus 0. I might not need the 0, but I might. And then 3x plus 3. Now I did the unfactored form, so all I did was just multiply that out so I could get that, so I could put it into a division box. So what would I multiply 3x by to get x squared? Now here's, fractions are going to come across, but we only have to use them like twice, so it's going to be okay. I need a third of that, so I need 1/3 x. So I multiply, I get 1/3 times 3 is 1, so that's 1x squared. 1/3 times 3 is 1, so that's 1x. I'm subtracting, so I change the sign of both. And then I do it again. Now you have to think fractions. How could I change a 3 into a 2? Well, first I need to multiply by 2 and then divide off the 3, so 2/3. So that's plus 2/3. And don't go any further. As long as you got that correct, you're done. You don't have to do the full division for the slant asymptote as long as you get to that, because you're looking for a y equals mx plus b. So our slant is 1/3 x plus 2/3. So that's probably the hardest, weirdest thing to wrap your head around for those. So start at 2/3. It's about here, just guesstimate. Count up 1 over 3. I'm going to go down 1 and to the left 3 because I want to stretch across that graph, and I'm going to make that a dashed line. Now remember, one with a slant asymptote, it is tucked between the x's, so it's either going to go like that or it's going to go like that. This to me makes it seem like it's hard for it to be a function. It will be, but I wonder if it's maybe doing that. We'll see. Okay, so we've done step 1 and 2. Now let's go to step 3. That's our intercepts. The x-intercept is where the top factored version equals 0. So that's where x equals 0 and x plus 3 equals 0. So we hit the x-axis at 0 and at negative 3. So we've kind of found where our x is going to be. See how we have to be here and then across from the x? We're always making an x. We're always making an x for the ones with slants. So we kind of have everything we need, but let's put in 0. If we have an x-intercept of 0, you're also going to get a y-intercept of 0. So 3 is done. Now we're ready to graph it. Like I said, I think we have everything we need. Follow this, follow that. Follow this, follow that. The only thing I have to put on is the hole. I didn't put that one on, so let's do that. The hole occurs at 3, remember? 3. So let's just plug 3 into. You always have to plug it into the simplified version. It won't work in the original version. So we need to plug it into that. So if we plug in 3 into that, we get 3 times 6 over 3 times 4. The 3's cancel. You get 6 over 4, which is 3 over 2, or 1.5. So go over to the graph at the point 3, 1.5, put a hole. So over 3 and 1.5. 1, 2, 3, 1.5. Put a very kind of exaggerated hole. Okay, so I think we have everything we need there. We have the domain, we have factored it, we found a slant, and there we go. The other ones I think are a little easier than that, okay? So you have 2 homeworks that are due either Friday or Saturday. Just check Google Classroom for me to see what those dates are. You have 5-6B and 5-6C. The 5-6 Alex is not something that you want to wait until next weekend to get it done. I would suggest over the next few days that you have off working on the 5-6 Alex so that when you see me the next time, you can ask any questions about Alex. Okay. The chapter 5 test is coming. We have finished chapter 5. So being that, you know, there's a lot of stuff in chapter 5. So please make sure to turn these notes in. For the rest of class, please work on your 5-6 homeworks or your 5-6 Alex. And then when I see you next, I can go over any ones that you're stuck on. And then if, well, after we've gone over any questions, we do have to start thinking about the chapter test, which is next week.